Okay, so hello. And then sekarang we do right now worksheet for 6.15, which is also the same chapter, which is the multiface. Okay, so let's go. I will read the questions first. 10% aqueous solution of sodium chloride is fed to an evaporative crystallizer operated under partial vacuum. Evaporation of water concentrates the remaining solution beyond its saturation point. The crystallizer product is a slurry of solid crystals suspended in a saturated solution at 80 degrees Celsius, and the unit is to produce 1000 kilogram sodium chloride solid per hour. If the evaporation rate is 20 times the production of crystalline sodium chloride, determine the ratio of the solution mass flow rate to the feed stream. So basically, before we are doing anything, we need to do the block diagram first to make it clearer. So yeah, I will do the block diagram first, and then we extract the information from the questions. Oops. Okay, why I did two errors output, because we have two things, which is first we have the one. Number one, it fits fit itself, because it says 10% aqueous solutions of sodium chloride. So which is we have here is 0.1 weight is kg natrium chloride over per kg, and then the rest is water, because it is this question said aqueous solution, right? So we need to use the remaining is 0.9, which is for water, weight for water. Okay, then the next sentence will be evaporations of water concentrate the remaining solution beyond its saturation point. It is important to know or to understand that sentence, but we will use that information after this. This is the crystallize, and then this crystallizer product is a slurry of solid crystals suspended in a saturated solution at 80 degrees Celsius. So I will say this is one of the stream out, which is M2, which is the slurry or either saturated solution. Okay, at how much temperature is it, which is T equals to 80 degrees Celsius, and we know that the unit will be produce 1000 kgs per kg natrium chloride per hour, which is we have here M2, which is M4, I mean, because it is berasingan, so we put here 1000 kg per hour for NaCl solid. Okay, because M2 is saturated solution, and then M4 is what we produce. You see the product. Okay, and then if the evaporation rate is 20 times the production of crystalline and NaCl, which is the evaporation rate gives the hint we have another stream, which is we remove the water. So M3 for H2O remove, we don't know how much, but they said 20 times of the production of NaCl crystallize, so solid lah. And we can know that 20 times, which is 20 times by 1000, which is this, we get 20,000. Yes, 20,000 kilogram per hour. So this is our M3. Okay, and what they want, They want the ratio of the solution mass flow rate to the feed stream, which is M2 over M1. Okay, this is our target. So basically we need to start with the hint that they give, which is the solubility per, which is gram per 100 gram of H2O, which is here we can denote it as using this table. In this case, the questions asks about the sodium chloride, so we just use the sodium chloride. Okay, the legend of sodium chloride, which is the triangle one. So this bit, okay, these things. So we can note that this is gram natrium chloride per gram H2O here. Okay, that is our target to get the question, to get the answer. Okay, so next we will use these things. Okay, so the solubility at the 80 degrees Celsius. Why? Because we have here 80 degrees Celsius, so we need to find the solubility of the sodium chloride. If it is dissolved or soluble in 100 gram of water, so solubility of NaCl at 80 degrees Celsius here. So we can find here using this graph 80 degrees Celsius, and we tarik to the tepi, and then we get approximately 40 gram. So 40 gram of NaCl will dissolve in 100 gram of H2O. We get 0.4 gram NaCl over gram H2O. And then as we know, here we have X2 NaCl equals to tak tahu, and X H2O 2 instead number 2 we got tak tahu juga. So as we said here, we can use the information which is X NaCl over X NaCl plus X H2O. You get the answer of 0.4 over 0.4 plus 1 because of this fella. Okay, and you got the answer. Wait, okay, kilogram, sorry, kilogram. Okay, then you get the answer of X NaCl, which is 0.246 to 2x6. Oh, sorry, I think I made something wrong here. Okay, it is actually M, because we want to find the mass fraction, right? So M. Okay, 0.4 over 0.4 plus 1, and then we get 0.286 kg NaCl over kg mixture. So at X-H2O, we can find by 1 minus X NaCl2, stream number 2, and we get the answer lah, 0.286 equals to 0.714 kilogram H2O per kilogram. So this is our answer in stream number 2 here. Okay, so we can do the mass balance. We already have a complete the complete information. So we do the mass balance. We do the total balance first, TB balance. equals to M1, M1, here M1 equals to M2 plus M3 plus N4. So M1 equals to M2 plus M3 plus M4. We can also put already the information we have, which is M1 plus M1 equals to M2 plus M3, which is our production of for evaporation rate, which is the water removed 20,000 kilogram plus with 1000. So we get M1 M2 plus 21,000, and then you get M1 minus M2 equals to 21,000. So this is your first equation. So next we have an ACL balance. So X and ACL1 M1 equals to, can find here, okay, X and ACL1 M1. What we have here is M2, X and ACL2, and M4. So put it in the equation. Now to M2 plus 1000. So we just put the formula in, the information we have. M2 plus 1000, and we arrange the formula, the equation. So it will be your second equation. So you can use your calculator, magic tools, and then you get M1 M2, right? So M1 equals to 27,111.11 kg per hour, and then one M2 is 6,111.11 kg per hour. This is not your last step, your last answer, because they want the ratio of the solution mass flow rate to the feed stream. So M2 over M1 times by 100%, or you can just you can use 100% to find the percentage, or you don't want to use this one also can lah. Okay, so 6111.11 over 27,111.11 times by 100%, and you get the answer, which is 22.5%. This will be your last answer. Okay, so basically use or utilize all your information given, and you can mix and match the hint given by the questions and the graph itself, and you can relate with the mass balance, and you can find the answer lastly. So this is your answer, 22.5%. So yeah, that's all for worksheet 6.15. Thank you.